Unit 15-1. Equations consisting of combined operations. Okay, right there on page 445 in the blue box, they give you some guidelines as to how you approach this thing. Because we've got all this stuff right here. Here's our example equation. And we need to know, what do we do first in here? Well, first thing is remove parentheses. So here's a set of parentheses right here that we need to remove. Well, if you remember from the order of operations, removing parentheses is one of the first things that you do. And to do that, you would just do the math operation within the parentheses. Well, what is x plus 6.35? I don't know. So there's another way to get rid of the parentheses without actually adding these two together, and it's a technique that we have not talked about yet, and it's called the distributive property. So this is a multiplication right here, so that means that I'm taking negative 4.73 and multiplying it by what's inside the parentheses, and because I have more than one term in there, I'm going to multiply this by each of the things inside the parentheses. So the first thing I'm going to do is change that. So I'm going to write everything else the way it is, 0.13x. Now I'm going to distribute that negative 4.73. That negative goes with it. So negative times a positive is a negative. 4.73 times x. Now negative times a positive is a negative. And 4.73 times 6.35, not really something I can do in my head very quickly, is, now I'm not going to round it at this point, 30.0355, because it's somewhat manageable. So I'm not going to round it. I won't round until the end if I have to. And that equals, and now no parentheses over here to take care of, so I will just continue this. I'm only going to do one step at a time. Okay, so next thing that it says to do is combine like terms on each side. So let's see here. I've got, this is a constant term. Here's two x terms. So I will combine them. And so 0.13 minus 4.73 is a negative 4.6. So I've got a negative 4.6x and then minus 30.0355 equals nothing to combine on this side. So I will just continue with the 5.06x minus 2.87. Now, what I need to do is I need to get the x's on one side and the constant terms on the other side. Now, it really doesn't matter which way you go here, but because I've got a positive right here and a negative right here, it would probably be better if I added 4.6x to this side to make this go away and then added 4.6x to this side. However, you could subtract it if you wanted to. Subtract 5.06. That would just give you a negative x on this side. And that's mathematically doable. Now, at the same time, I'm going to add 4.6x to this side and make it 0. I'm going to add 2.87 to this side to make that 0. So I need to add 4.6x to this side and add 2.87 to that side. So this will be 9.66x and Let me check out my calculator here. Negative 30.0355 plus 2.87 is a negative 27.1655. And now divide this by 9.66. Divide this by 9.66 divided by 9.66 equals negative 2.8. Ta-da! So one step at a time, and they give you some guidelines there. It's almost, when you get to the end, when you're adding and subtracting and multiplying and dividing, it's almost like doing the opposite of the order of operations. Almost. So let's take a look at the examples on page 446. And let's look at one of the first one, where we have 8x plus 12 equals 52. So the first thing that we want to do is get the variable terms. Any term with a variable in it, we want those on one side. So we got to get rid of this 12. So to make it 0, we subtract 12. And in order to maintain that equal sign as balance, I have to subtract 12 from this side. So 8x is equal to 40. Now I have to divide. I have to do the division principle. So divide by 8, that makes this a 1. Divide that side by 8, and we get x is equal to 5. And then you can always put the solution back into the original equation, and it should work. So 8 times 5 is 40. 40 plus 12 is 52. So yes, that is good. That works. Now I want to look at example number 3. Number 2 is just a lot of combining like terms. So let's take a look at example number 3. We have 14y minus 6, y minus 3 equals 22. Now I'll give you a few minutes. You can pause and try this one. Okay, so let's work through it. Did you pause or didn't you? I saw some of you doing it, but I didn't see everybody doing it. Yeah, that's right, you. No, I'm kidding. All right. I don't care if you did. First thing I need to do is get rid of these parentheses, because my unknown is inside the parentheses. So I can't subtract these two numbers because they're not like terms. So I have to distribute this negative 6 in. So I've got 14y. Negative times a positive is a negative. 6 times y is 6y. Negative times a negative is a positive. 6 times 3 is 18. And that equals 22. Now I can combine these two like terms. 14 minus 6 is 8. So I have, let me write it up here. I have 8y plus 18 equals 22. Subtract 18 from both sides. And 8y is equal to 4. Divide by 8, divide by 8, and I get y is equal to 1/2. Okay, so that's a good example of using the distributive property. Now, we hadn't talked about that before. Now let's take a look at 4 on page 447. We've done something similar to that. First, you would add 36.5 to both sides and then multiply by 6. But I want to concentrate on 5 because we haven't really done anything like this. And the reason why this is different is because the unknown r, what we're solving for, is in the denominator. So far, it's only been in the numerator. So let's say we've got 4 equals 130 divided by r plus 20. Okay, so how do we get this out? Now, there's more than one way to do this. There's actually 3 ways that we can do this. One way is if I just simply multiply by r plus 20. That's going to make this a 1. So 130 times 1 is 130. But I need to multiply this side by that as well. So 4, and then I'm going to use parentheses because I have to multiply it by the whole thing. Not just the r and not just the 20, but 4 has to be multiplied by both. R plus 20 equals 130. Distribute that. So I've got 4r plus 80 equals 130. All right. Now it's looking a little more like something we've seen. Subtract 80, and I've got 4r equals 50. Divide by 4, divide by 4. And 50 divided by 4 is 12.5. So R equals 12.5. Okay, so that's one way to do it. Now, another way to do that problem